All right, I shouldn't have stopped the recording. I'm going to add something to this because I forgot to say, I'll put this in a different color. For your mock exam, and I don't like to do it in this order, I'm going to tell you what dates it is. We're going to do the calculator for your response. For you guys, it'll be 4/29. For my B day, it'll be 4/30. Actually, I'll put them both on here. You guys just write 4/29 though. My B day will be 4/30. And then the non-calculator for your response, for you guys, it'll be 5/1. For my B day, it'll be 5/2. And then we'll come back and do the multiple choice. So this will be, for you guys, 5/3. For my B day, 5/6. And then this will be 5/7, 5/8. So I told you how many minutes it's worth. So like, for example, on the 29th, this will be 30 minutes of class, and we'll spend the rest of the time doing more practice and review. I'm not going to give you a whole mock exam like all at once. I can't, it's too much. So like this one, you'll spend 60 minutes doing that. And then the remainder of the time we'll practice something else. I usually do the practice first, so I'm not throwing it at you the second in the door. And then, yeah, at the bottom of this, put your exam is 5/13. Thank you for reminding me of that. I should have put that on there in the first place. All right, so we are going to do 2023, which is last year. This is calculator. And they gave us a table. Before you even read the problem, there's probably a Riemann sum in there. Like, do you get what I'm saying? Like, you want to start to anticipate it. So let's read and figure out what's going on. Customers at the gas station pumping gas into a tank. The rate of flow of gasoline is modeled by a differentiable function. Ooh, since it's differentiable, that means it's also continuous, probably going to come up. You want to start to anticipate that. And it is measured in what units? Something per something else. It's a velocity, it's a rate, a derivative, a slope, if you will, all those things. Time is in seconds since pumping began. You've all been to a gas station, right? Pumped gas. Like, imagine that. That's what's going on. Letter A, using correct units, interpret what that means in the context of the problem. I'm going to skip that for right now. Use a right Riemann sum with 3 sub-intervals. Let's circle them. 60 to 90, that's this one. 90 to 120, and then 120 to 135. So 3 sub-intervals to approximate that integral from 60 to 135. All right, so what are we going to put on the paper? We're doing a right Riemann sum. Yeah, so they're all different, the intervals, so you are going to have to write them out separately. So let's do the first one. 30, how'd you get 30? Because that's correct. The distance, and then which is the one on the right? 0.15. Plus, now let's do the next one. 30 times 0.1. And then the last one, 15 times 0.05. That is worth 2 points. It is 2 gimme points. And they started out with that. That was a very inviting problem. Now, the second part of that, part A, says interpret what that means. So you've got this rate of flow of gasoline, and then you did an integral of it. It's the amount. We went backwards, did an integral. If we had done a derivative, you'd be correct. We went the other way. So it's the amount of gasoline put in the tank from 60 to 135 seconds. However you word that, like in your own words, I would say this is, because that's the number that we got. This is the amount in gallons pumped in from 60 to 135 seconds. And then that is worth a point, that sentence. And we're on our way. All right, letter B. B says, must there exist a value of C from 60 to 120 where the slope is 0, derivative is 0, that means slope. So look at your table from 60 to 120, these right here. Does there need to be a derivative that's 0? Yes is the answer. There's 2 parts to this. First, you have to show that the slope comes out to 0. So it's going to be 0.1 minus 0.1 over what minus what? Look at your paper because I can't keep shifting this up and down. Yeah, 120 minus 60, that equals 0. You get a point for showing that. So even if you feel like you can't write the sentence, you get a point for that. So at least do that part. Does anyone remember what theorem this is? Mean value. Perfect. Okay, so you're going to have to start out with, since, what was the function? F of t is what? Differentiable. And write out the whole word. I don't know if they'll take diff on the AP exam. I accepted that, but I don't know if they will. Since the function is differentiable, f of t, then it is continuous. And they will not take the function is differentiable and continuous. You have to say, since it is differentiable, that means it is continuous. That's how they want it written. All right, since f of t is differentiable, then it is continuous. And then you just repeat the prompt, right? We already showed that this equals 0, so we're done with the math. What does it say? There must exist. Yeah, just read it off the paper. There must, I can't write and talk at the same time. Must exist a value C between 60 and 120 such that derivative of at C equals 0. I'm just copying it from them. By mean value theorem. And you can write MVT, they'll accept that. So you have to write yes in some capacity. The function is differentiable, therefore it is continuous. Repeat the prompt, and that whole sentence is worth a point. So like I said, it's worth 2. If you can't get the sentence, at least write the slope. You'll get 1 out of the 2. And I hope I've coached you from the beginning of the year to understand that 1 out of those 2 points is good. You guys all get that, right? I've graded your tests like that from the very beginning. All right, letter C. While I'm flipping this paper over, go ahead and read that. What's going on with C? A lot is, correct. Now they give you a really horrible function, but remember this is calculator. We have. Oh, is it?
I think so.
No, I think it's just going in. Rate of flow of gasoline can be modeled by that awful thing from 0 to 150. Oh, find the average rate. If I gave you a list of numbers and asked you to average them, what would you do? Add them up, divide by what you've got. So adding it up, leave a little gap here. Adding it up is the integral. It would be from when to when? 0 to 150 of that awful thing. And then what would go out front? To make it an average. Divided by. Yep, good. Perfect. Slam that in your calculator. That is the setup. Now you're going to put it in to your calculator. That is the setup. When it says show the setup for your calculations, it's that. Basically what they're saying is write down what you're putting in your calculator. Oh, and you better be in radians because there's trig here and it will be wrong if you're in degrees. They aren't going to give you a nice function. It's going to be awful. So 0.095 truncate because it involves not thinking. All right. So it was a point for the setup and a point for typing it in. All right. And then the last part there, using that model from part C, so that means this awful function, find the value of, oh, this is a gift. Find the value of G prime of 140. How do you put that in the calculator? How do you do a derivative in the calculator? Math 8. Do math 8. That question is a gift. You can definitely get that one as long as you can type it right. So math 8. And then you're gonna have to type that awful function again, I'm sorry. I really like that one. But again, here's the thing. This is gonna happen at the very end when you've been there forever and you're tired. So you can't overlook these gimme questions. Like that is an easy one, but you're gonna be exhausted and brain fried. So you have to have some stamina. Eat like a jar of tuna fish for breakfast or something. You know what I mean, though. You get what my point is taken. Negative 0.004. No, because they actually put that in the problem, so you don't have to. I wrote G prime of 140 equals, but if you just have that, you get a point for that. Now, it also says to do what? Interpret. All right. G is the, let me go back, rate of flow in gallons per second. We did a derivative, so it's a rate of a rate. Here's how I write it, so I don't have to write a rate of a rate. Is the rate increasing or is the rate decreasing? Okay, so you're gonna say the rate is decreasing 0.004. Now this one we do need units. It's 0.004 what? Gallons? Yep, per second squared. And you can write per second. Rate is decreasing that many gallons per second squared, and they will not give it to you unless you say something else. At time 140 seconds. And so it's a point for that answer. Count it up, it should be 9. Did I add it up right? I didn't miss one? So look back through that. How many out of 9 do you think you would have gotten? Would you have gotten these two probably? These two sentences are hard, so I'll give you that. Out of here, if you at least got the slope, I'd be super proud of you. Okay, so that'd be at 3. And then I think these 4 were all pretty manageable. But even if you didn't understand what that one was asking, 3, 4, 5, you'd still be at 5 out of 9, which is plenty good enough. All right. I have a couple of minutes before lunch. Let's go to number 3. I'm going to skip the other calculator one for right now, and we'll start 3 before lunch. We'll finish it after. My videos are going to be all chopped up to bits here, but that's all right. So last year, this is last year's exam. They did give a slope field, which means they probably won't on yours. They only usually do this every few years, but we're still going to go over it. So letter A says, sketch the solution curve through the point 0.05. So do you see that point right there? They even started it for you at 0.5. Can you go ahead and draw that in? Like swim with the current? You just need to make sure you go all the way to the edges. It was actually a pretty easy one because there wasn't too much to it. That was worth the point. Does yours look vaguely like that? I read the scoring guidelines. Basically, if you didn't like cross any of the slopes egregiously, and as long as you didn't cross the asymptote, they gave it to you. So that's pretty good. All right, and then I want to get through part B. I think we can do part B before the seniors leave here. So it says use the line tangent to the graph. You're going to have to write the equation of a tangent line. What 2 things do you need to write an equation? A point and a slope. Now, I think that they gave us the point. Read through there. What is our point? No, 2 is what we want to plug in eventually. So it's going to be 0 something. I think the other part's back up at the top. What's your initial condition? I think it's 0.5, 0.5. Okay. Slope comes from derivative. Here's your derivative, dm dt. It's m because is this milk? We're taking milk out of, I should have read it. Milk is taken out of a refrigerator and put in a pan of water. We're warming up the milk for our child, okay? So that's why it's dm dt. M was for milk. So we're going to plug in, what is m? What is the milk? Is it the 0 or the 5? Because we have to plug in M. Is M the 0 or the 5? M is the 5. This is time. And this is milk temperature. All right. Or you could look at the graph. All right. But you're going to plug in 5 for M. All right. So here we go. 40 minus 5, 35 times a fourth. So 35 fourths. I only got 1 minute left. So let's put this together. It would look like that. I'm going to go ahead and assume you guys could do that. All right. And then, and after I get this answer, I'm going to tell you what the points were. So hold on a second. What did we want to plug in? 2. I dislike that because where did we write our tangent line? At 0. 2 is not very close to 0 if you're thinking about like, so I didn't like that one. But anyway, y is approximately 35 fourths, 2 minus 0, and then one other thing, plus 5. It was a point for getting this slope. So if you got the 35 fourths, you got a point. And then it was a point for that answer.